Let me share. Is it I'm sharing already? Oh, not yet. I think. Okay. So I hope that my voice is clear and you can see this PowerPoint slide. Okay. Tutorial 2. Determine the horizon and vertical component of direction support and neglect the thickness of beam. Okay, so this one's if based on these questions, okay. So what you have to do, definitely you have to draw free body diagrams. Okay. So how to draw the free body diagrams? If you look at here, there's two support reactions. Okay, one and two. This one is roller, and well, this one is what we call it as what we call it. Forgot. Okay. So this one roller, and another one is the external pin. Okay. So how to draw the free body diagrams? Okay, please remember first step, you have to draw the free body diagrams. Okay, free body diagram. F B. Okay, so F. So how to draw? Just draw. Okay, so please make sure draw lah. Okay, so where's the picture? Okay, so we have this one, and this one. Right, and then at point B. Okay, and as well as here. Okay, so we have also this one, 900 Newton, 10 Newton meter. This one is 200 Newton. So just 5, 4, 3. Okay. What else? This one we just denote as a BY. Support reaction just using the what is it? The letter. Okay. No need F, A, Y, and A. AX. Okay. And then the distance. This one. Okay. This one is the free body diagram. 1.5 meter. 1.5 meter. 1.5 meter. Okay. So this is point B. This is point A. Okay, so this is the whole free body diagrams. Okay, so and then we have to how to say observe where is at least one nouns and two unknowns. Okay, if you look at here that we can solve total fx lah. Okay, go to 0. Okay, so using equation of equilibrium ax plus 2500. Okay, 35. 35. This one 2500 here, up here. So please calculate AX. Okay, Newton. Do not forget the unit. Without unit, 0. Okay, once you determine AX, this one. Once you determine AX, okay. What you have to do is, you have to determine by using this one we define, we define counterclockwise as a positive. Yesterday I thought is a clockwise, but we define counterclockwise. Okay, so by time 3, okay, by this one to A, right? Point A, right? This one, this point. Okay, because you hold this point A, so it's gonna be uh, this one is turned to clockwise, right? Okay, clockwise, yes. Minus 2500, okay, times 45, 1.5 meter. Okay, minus 900, go to 0. So please determine by. Okay, so and then you can determine by. Okay, so once you determine by, what you have to do, you have to calculate by already, ay. So ay total fy lah. Okay, so total, so okay, ay plus 1300, 0.5. Okay, by, okay, ay by, you have to determine by. Okay, minus 2500, 45. So you can get ay. This determine ax, by, and also ay. Give me the answer. What is the answer? Ax 1500. Okay, 1500. Ax 1500. How about by? Fay. Okay, this one 1300. Very good. By. And then this one 700. Okay, very good. Anyone can get this answer, right? Okay. Not negative. Yes, Fax not negative. Okay, Fax not negative. Okay, it's positive. By is all positive. Okay. Okay, so we move to the method of the sections. Okay, so method of section is another alternative that another method that you can use to determines the internal loading of in the members. So just now we just how to say, we calculate the force at the end of the truss, right? Is it at the pin or joint around here, right? But how about if you want to calculate, if there's a many joint actually like this one, right? Okay, so if you want to calculate each joint, I think is take a time consuming, okay, and tedious, okay, especially if you just want to determine the force at this point, right? Is it you want to determine all the joints, okay, the force at each members? I don't think so. So by using the method of section, you can reduce the times. Okay, so if you look at here that this is the example of the figure, right? You want to determine the I think of force VC, NC, and also MC lah. This one internal loading members. Okay. Okay. So this method is used to determine the internal loading in members. Okay. Uh, if a body in equilibrium, so of course, we have to consider in equilibrium. Any part of the body is also equilibrium, meaning that if you cut here, okay, between two segments, okay. So if you cut here, as I told you, it's going to be cancel out each other. Okay, if this one is in tension, right? Okay, this one also should be opposite, and this one also is opposite. If you add this both force is going to be like it become to zero lah. Okay, similarly also for the compression, internal compression force. Okay, so this is what we want to calculate the internal loadings in each members in the truss. Okay. Okay, so if you look at here in design also, right, so material use is able to resist the loading. Definitely, if not, is your material is going to be fails. Okay, finding the force acting within the members to make sure the material can resist those loads. Okay, so internal loadings we can determine by using method of sections. So how can we determine that internal loadings? Okay. So first, definitely you have to draw the free body diagram. If you look at here, this is but I would like to suggest that you have to draw the full free body diagram. This is a full free body diagram from this what is it? This bar. Okay. So if you look at here, this is by just like a previous example, right? You draw all the free body diagram, and then you have to cut beams into the segment, right? Draw a diagram for of the what is it? The system that you cut. Okay, and then you can apply question of equilibriums. Okay, so this is I have a normal stress and I have a moment as well as what we call this one VC. I forgot this one. Uh, Later I will check. Yeah, internal shear force. Internal shear force. Okay. Internal moment and as well as internal axial loadings. One you cut that one. Okay. This one, yeah. Okay. This is in chapter 5 lah actually. We are not. I think we cover only some part of this internal axial loading, internal moment and as well as internal shear force. Okay, in detail you can refer in chapter 5 in mechanics of materials. Okay, so and finally you have to apply the equation of equilibriums. Okay, so segment and also the convections convention, not convection. If you look at here that similarly also for the shear force, internal shear force and also moment. So if you cut on the left side in going down, so it will be opposite lah. Similarly also moment if counterclockwise, this one is going to be clockwise. Okay, so the loads on the left and right side are the section are equal in magnitude but opposite in directions. Okay, so the net loads are zero at the sections when you combine this left and right section. Okay, so how can we develop in the structure member? Of course, procedure of the analysis. You have to consider the support reaction, free body diagram, and also equation of equilibrium. Okay. First, you have to determine support reaction. So, meaning that you have to draw the whole free body diagram or entire free body diagram. Okay, if you look at here. Okay. On Vonsiu, if negative, meaning that the direction is opposite side. Okay. So you have to change. It's the opposite side. Okay. Meaning that if arrow once for the what is it, the support reactions, okay, when you consider, sorry, I have to answer the question from the chat box. If once you guess for the support reaction, right, especially for the yeah, support reactions, if you guess for AY is going up, okay, and then you got a negative value, right? So meaning that the correct one is to the opposite side. Okay, so this is the correct one. Okay, so meaning that is if going down is a positive. Your value is going to be positive. Okay. Session at the place where you need to determine the internal force. Okay, meaning that you have to cut that system. Okay, and you have to analyze. Okay, and draw free body diagram for the of the sections. Okay, there's a and then you have to include the what is it the internals force, okay, for the cut surface NV and NV and also N is a internal axial loading, internal shear force, and also internal moment. Okay, so similarly you have to determine their sense by inspection lah, by correct sense lah. If after calculate you get negative, so you have to correct that, maybe it's the opposite side. Okay, it's opposite, and then you apply the equation of equilibriums. Okay, equation of equilibriums total, uh, this is by definition lah. This is a positive F1. Right. So, oh, total F, total Fy. Okay. I think so I wrote here. Oh yes, sir. Total total F0, Fy, and Fl, and also total moment. Okay. See, if the negative result, the sign is the opposite. Meaning that opposite. To know that. Okay. The sense is opposite. So if you the first guess you, fx is this side, right? And then you get negative, meaning that is the opposite side. Okay. Okay. So cable. Oh, this one. Okay, okay. Yes, that's correct. So if you look at here, that this is the examples how to calculate how can we apply this method of sections. Okay, so first, if you look at here, that 500 kilograms of engine is suspended from the crane boom as shown, and determine the resultant internal loading acting on the cross sections of the boom at point E. Okay, so meaning that here, okay, this point E. Resultant internal loading. Okay, meaning that you have to determine the internal axial force. This one, and E or S. VE as well as ME. This is internal resultant internal loading. Okay. Okay. Similarly, also what you have to do, if you look at here, we have to draw free body diagrams. Okay, definitely. Don't forget to draw free body diagram based on the procedure. So draw whole free body diagrams. Okay, like this one. Okay, and then this one, right? Okay, to decide actually, because there's a force to the there's a weight here. Okay, meaning that based on the sense, this one try is going to be tension. It's going to be tension. So based on your sense, decide. Right. Okay. And this one also. Okay. Right. Okay. What else? There's this one pin here. Right. So pin just based on the sense. Right. Decide. Right. Okay. What else? And the distance. Okay. So the distance, get here that 2 meter, 2 meter. This one is 500 kilogram. Is it 500 kilogram times with 9.81? This one FCD. because this is point C, this one point B, point E here, right? Uh, what else? This one AY, AX. Okay, okay. 2 meter, 2 meter, 1 meter, 1.5. Okay, so if you calculate this one, all right. Based on the triangles, this one is going to be, the triangle is going to be uh 435. Okay, 435. Okay, so just go here lah. 3, 4, 5 lah. Okay, okay, this is the whole free body diagram. So what you have to do, you have to determine all the what's it, the unknowns. Okay, this is have how many unknowns? FCD, AX, and AY. Okay, why we have to determine this by using method of joints? Because you want to determine the internal loadings. Okay, and internal loading is have 3 unknowns. Okay, without the determination of force at the support reaction and also FCD, I don't think you can calculate the internal force. Okay, so first I think we can do by using a moment at A. Okay, total moment at A. Okay, this one 0. So you can calculate FCD lah. Okay, and then total Fx is 0. So you can calculate AX. Okay, and then as total Fy total 0. So you can calculate AY. Okay. Okay. Once you determine FCD, AX, and also AY, okay, so you have to draw internals. You have to draw the cut system lah, the free body diagrams. Okay. So if you look at here, that they have a arrow here, and ME lah. One is ME at point E, right? ME and also VE. Okay, and you already have calculate this one, AX and AY. Okay, so this is only 1 meter lah. And this is point A. This is point E. Okay, so by using equation of equilibrium lah, same. If you look at here, you later you gonna determine this one lah, AX and AY, right? Since on the left, on the x-axis only one unknown, so you can determine NE. And then you can determine AY because one unknown also, right? So you can determine AY lah. And then internal moments, you can do moment at E lah, only at E. So meaning that this one is only AY, ME AY times with the distance 1 meter. Okay, so you can get ME lah. Okay. Why we do at ME? Because we can reduce number of unknowns. You can do also at a point A actually. If that's the meter, it should be the answer is the same. Okay, if you do at point A, the calculation should be VE times with the distance is the same. Okay, AY and AX, the distance is 0. Okay, plus with the ME is the same. So, okay. So this is the how the solutions. That's why I just make it. I just go through in a brief. Okay, you can refer here. This one 12, FCD, AX, and AY. Okay, and that's using a cut system by using method of sections, so that you can calculate the internals loadings for the members. Okay, is it clear? It's just recall back what you have learned in the static, right? Any questions about method of sections? Oh, if you have no questions, could you please do this tutorial 3? Okay. How can you apply this method of sections? This is the, I think, one of the simplest method. Okay. Betul, untuk chapter ni buku teks guna buku. Yeah, buku. This is not a foundation material science and engineering. This is a mechanics of materials. Okay, mechanics of materials. The author is Hibbeler or Beer. Beer. For me, my reference is Beer lah. The author, mechanics of material. Yes, by the inspection, right? You have to determine by the inspection, right? Is why the AY downward is what? It doesn't matter. Okay, AY this one. If you want, if you sense that the is not upward going up, okay, if upward, later if your answer is negative, let's see this one, right? If uh you guess this one is going to upward, right? Okay, AY plus FCD 500, right? So you can get negative, meaning that the correct one is to the downward. Okay, it doesn't matter. It's just on your sense. Okay, just correct the answer after the, if negative result, the sense is the opposite. Okay, meaning that when you guess is downward, meaning that is the correct one. Is the correct answer. 2 4 is a, the negative is just showing that the direction of the your, what is it, the force, okay, or the arrow. Okay, doesn't matter. Any questions more? Saya dah jawab ke semua? Okay. The direction is just now is determined. Yeah, inspection, just inspection. It doesn't matter. If you get negative, it's opposite. That's all. Okay, okay, can you do this? Tutorial 3? Where's the Jambot? Let me share the Jambot. Wait, Jambot. Oh, I have to wait. I'm sharing. Buat dulu you do first. Give you the Jambot link. It's yesterday, like yesterday. The Jambot is yesterday. Oh, do first. I give you around 5 to 10 minutes. Slightly masuk. Sekejap lambat tak? This one I sharing. Please do first in A4 paper. Alamak, annotated lah. Check. And there's a link for the Jamboard. Please do. Go to page. Yesterday until page, which page? 13, right? Which page? Mana yang kosong? Pergi page yang kosong. Oh, 16. Eh, malam tak ada save ke? Kenapa macam semalam macam saya kasih ni? Saya kasih link yang lain. Okay, page 16. Ya, saya sharing the, how to say, sharing the screen. Sharing the screen. Allah. Tak boleh. Aduh. Eh, hmm. Boleh nampak how that you can see. Okay, how can you do this one? Okay, what you have to do, of course, loading on the trash shows the first in member BC, and if you look at here that you have to cut around here lah. This one. Okay, and you take this one. Okay, can you draw? So if you draw the free body diagrams, things like this. Like this. This side, and this side. So this one is gonna be point B now. This one is FEF, FBE, FBE. This one, okay. FCB. Okay. Yes, this is point D, point E. This is point C. So 10 kilonewton. A 5 kilonewton. 5 kilonewtons. Okay. So 4 meter. Look at here that this one is 4 meter. 4 meter. Okay. This one is 45 degree. Because the same length. Okay. This is the free body diagram. So can you solve it? Question of equilibrium. What's the answer? So, what's the answer? FBE, we have unknowns here. FBE, FEF, FCB. So if you analyze here, because you cut here, right? Okay. So if equation of equilibriums, okay. So you can analyze FCB to the right side, and then we have this one non so only and then another one 10, right? So you can start with the total effect lah, go to 0. Okay, to determine FBE. Can you determine FBE? Okay, is it in tension or compression? FBE 14.4 IFT. How can you determine the F? FBT 14.4, FBC 0. Please check your calculation. Okay, so if you look at here, FBE to the FBE is to the right side, right? Okay, if you look at here, that FBE, this one lah, FB. Okay, so look at here. Yes, 21.23. Yes, she's that. So Shui. Okay, that is correct answer. So if you look at here, because only take on the x-axis, okay, 5 kilonewton times with 10 kilonewton, okay, minus with the FBE, okay, because FBE this one, right? This one FBE, right? So it's going downward, okay. So meaning that it's cos 45 lah. FBE cos 45 degree equal to, you can get answer. Okay. So once you determine the FBE, okay, you can determine total moment at point E. Okay, total moment at point E. Okay, if total moment at point E equal to 0, okay, so you can determine FCB. Okay, because you already minimize the number of nons. That's why you use total ME at point E. Okay, so if you look at that, you can get FCB lah. Okay, -4, -5 lah, because this one lah, this one is gonna be uh, clockwise, 5 kilonewtons time with the 4 meters, right? For this one, of course, it's -5 lah, because we define counterclockwise as a positive. It's time 4. Okay, plus FCB. FCB this one times with the 4. FCB is gonna be positive. If you look at here, that FCB, right? If you hold point E and then you move, okay, it's gonna be to this side. Okay. Okay. So FCB times with the 4, number with 4 equal to 0. So you can get FC. Okay. So this one in tension, okay? Tension. Tension, this one also in tension. Okay, tension is a positive lah. Compression is negative. Opposite side. Okay, and then I use a method at the point B lah. Moment at point B. For the moment at point B, you can calculate this one, 5 kilonewton, by using 5 kilonewtons. And then 10, okay, 10 kilonewtons, this one. And then 5 times with, which one? 5 times 4. Oh, sorry. This one times with the now 8 lah, because from point B to point D is a 8 meter, and this one is times with 4. This one 5 kilonewtons, right? Okay, and then FEF. FEF. times with 4. So you can get FEF. Okay. Is it clear? Please calculate FCB and FE. FBE. FBE. FBE 21.2. No need to send me the privately. Just send to everyone the answer. Okay. 21 point. This one. Patutlah tak tahu eh. FBE is 21.2 kilonewton. Intention. Okay. FCB 5 kilonewton lah. Intention. FBE. And then FEF. This one already. Sorry. Same lah, 21.2. The FCB is 5 kilonewton. And then you have to calculate FEF. Okay, this one in compression. Compression, I think you get a negative value because it's just the first case, right? Okay, you get negative value. So once you get negative value, like this one, the answer is 25 kilonewtons. Okay, 25 kilonewtons. So meaning that 25 are positive. You make it positive, and it is compression. Okay, it is compression. Okay, clear, right? Or not clear? Okay, tutorials a 4. If you look at here, it's already cut. You have to determine the force, okay, in member GE and also GC, BC. This one tutorial 4. Of course, you have to draw the free body diagram, the whole free body diagram. Look at here. Okay, do not forget, because you have to determine the GE, right? GE. GC and also BC lah. Okay, all free body diagram. Okay, because if you want to determine this GE, BC and C, you need the value for the this one support reaction. This one. Okay, if not you cannot determine. That's why you need to draw the full body diagrams and determine AX, AY, and also this one. Okay, DY. Okay, this one already have answer. You can try. Similarly, also for tutorial 5, you have to draw full free body diagrams. Okay, there's a 2 point here you have to cut. Okay, point E and point this one between BA and also ED. Okay, this one. Okay, first you can start with the point this one, this one, and then the second you can do for the point E. Okay, also have the answer. Okay, and then tutorial 6. Tutorial 6 also have the answer. You can try this one. Okay, any questions about the method of section? Boleh? Any questions? Before we move to the axial loading, normal stress. Or you want do more example? Anyone can respond? Clear? So how to determine whether want to use section at the left or right? Okay. How to determine actually is depending of number of unknowns lah. Okay, at the left or right. If you see that right side is more unknowns rather than left side, so you choose the left side lah. This doesn't matter actually. Okay, method of section, whether you want to choose left or right. This doesn't matter unless you have enough information. Now you have enough number of knowns. Okay, this doesn't matter. Okay, for example, like this one, right? Whether you want to choose left or right, it doesn't matter. The answer should be the same. If not the same, if you try when you calculate on the left side and it's not the same with the right side, maybe something wrong with your calculation. Okay, you can try this one at the left or right side. Okay, should be the same. The force at member GE, GC or GB. Okay, because this one I think for both sides is uh, not really difference in terms of calculations. Okay, for me this one I choose the left side. You can try on the right side. Okay, so it should be the same this answer. Okay, is it clear? Okay, similar. This one, if this one is also the same, it doesn't matter. But I'm not sure in terms of calculation. I think 1, 2, 3, 4. 1, 2, 3, 4. Same for unknowns here. So it doesn't matter. Okay, if you want to start on the left or right side. Okay. Okay, clear, right? But if this one, right? Wait, total 6. Total 5, total 6. If this one, BC and CF, where is the CF? And FE. Cut here lah. Cut here. Okay. But this one, I think you have to determine also the full free body diagrams actually. Okay. Because there's a 2 pins here. Okay. And then I think you can choose to calculate by using, or you just, I'm not sure this one, you can start here. From here. You can take. Okay. Just on the right side. Sure. Okay. So yeah, I think it's clear where which one you want to choose at the left or right. It doesn't matter. Okay, it's up to you. Okay, just try and error. Do practice. Okay, so let's move. We have another around 30 minutes. Okay, I think we can't finish today. We can continue next week. Yeah, okay. Uh, let's we continue on the ideal. Is it clear for method of join and also method of section? Because method of join and method of section you're going to use for the normal stress, so the calculation of normal stress, and also for chapter 2, chapter 3, especially method of section. Okay, so this is important. Method of sections, we have to calculate the axial load and also normal stress by using method of section because it's cut by cut, right? Okay, especially on the road. What else? The shear stress. Okay, you have to make using a method of section. Okay, that is important because we want to uh in by method of join is I told you is a time consuming, right? Okay, So let's see, this one is for the definition of normal stress. Okay, if you look at here, the resultant of the internal force of for an axial loaded member is normal to a section cut perpendicular to the member of axis. So meaning that is this one. Okay, you give a force, this one, then you the opposite side, delta F divided by the area. Okay, so this is what we call it as a normal stress. Okay, so we can simplify it to as average of delta F, this one. Okay, yes, that should be perpendicular. Okay, so whether you compress or you pull or you compress, okay, that is axial force. Okay, it should be perpendicular. This is a normal press. It's not something like you, how to say, it's not like this one. You put a weight, right, like this, and then you want to find this one. It's just like this one, whether you pull or you compress. Okay, this one, pull or compress. Okay, so normal stress, average normal stress is a P divided by A lah. Okay, this is a general uh, equations. Okay, that you have to use to calculate the normal stress, because later we will have to calculate the deformation. At this chapter we did not uh, consider the deformations once you pull or you compress. Okay, or you put the weights on the members lah. Okay, so that is the importance of calculation of the normal stress, especially to determine the deformations when you give a force. Okay. Okay, so just remember this one. Okay, how to use P is the force, E is the area of the sections. Okay, we call it as a normal stress average. Okay, so what you have to do is you have to draw the entire free body diagram actually. Okay, and also support reaction. So for example, this one, right? Since this is an unknowns, okay, this is unknown. Okay, unknowns. So what you have to do, you have to calculate, you have to determine all the unknowns first. Okay. However, AC and ACY cannot be determined from static analysis. So what we have to do here, we have to use the what we call it as if you still remember the you can also determine by using a trigonometry lah. If you if you still remember lah, in static, right? Okay. So this one we can determine. This one is actually is a method of joining. Okay. So as this one, okay. So we use the triangles, okay, to determine all the force first. Okay, so you have to remember by using a method of join. Okay. Okay, so for the normal stress and stress analysis, if you look at here, that if we have a structure just now, just similarly like this, right? We already determined for each members the force. Okay. From the static analysis, okay, we determine from the method of join or method of junction, we can get FAB and also FBC, right? This one is already explained in the previous section, right? So I don't think I can explain in details because this is just a method of join and also method of sections. Okay, so once you determine FA and also FBC for these truss or members, okay, from the static analysis, right? FAB 40 kN, FBC at any section through member BC, meaning that where's the BC? This one to this one. Okay, normal stress is P divided by A lah, because we determine already a member of BC, this one, right? Okay, so P divided by A. Okay, we know the cross section area of the road, this one. Okay, because it's given 20 millimeter, right? Okay, so you can get 159 megapascal. Is it the properties of steel allowable stress of steel if we determines the normal stress of total normal stress of the beam is 165, meaning that sigma BC, okay, we call it as sigma BC is lower than sigma alls. Okay, so meaning that this truss can I means not fail lah. Okay, this is the maximum. This is the maximum force that you can apply or introduce to this member. Okay, so in conclusion, the strength of member BC is adequate to support 30 kilonewton load because we want to this one at 30 kilonewtons, right? Okay, because it's below than 165 megapascal. Okay, Okay. Other than we determines the allowable of the load that we can apply for the members, we also can determine the appropriate diameter or dimension. Okay. Because in terms of course, we have to consider whether you want to use a very large area or large dimensions or just small is enough. Okay. What is the optimum value that we can determine, right? Yeah. So if you look at here, from this is just whether we want to check at the 30 kilonewton is can adequate to support this 30 kilonewton or not for this truss, right? Okay. Another one is we can check okay the diameter also. Okay, what is the minimum diameter or appropriate diameter for the roads, lah? Okay, if you look at here that is given, right? Rod from the aluminiums, okay, is construct from the aluminiums 100 megapascal. What is the appropriate charge for the rod diameter? The load is the same of 30 kilonewtons. So we just do a back calculation from the normal stress calculation. Okay, sigma all divided by P divided by A. Okay, just rearrange this equation. Okay, A equal to P divided by sigma. Okay, A, if you look at here that the rod, right? Rod, of course, by the area is D square. Eh? Right. So just replace here. Pi D square over 4 P divided by sigma all. Okay. So just rearrange equations. Okay. So you can get this one, this final equation. Okay. This also you have to remember. You have to know how to use this equation. Okay. D square P lah. P what else? Sigma all. Okay. Times 4 divided by pi. This one. Okay, so you can know lah, because sigma all is given. So what is the minimum diameter? The minimum. Okay, just rearrange them. So that can see, right? 26 millimeter or more diameter is adequate. Don't use 25 or below than 26 lah. It's going to be filled with the 30 kilonewtons. Okay. Okay. So we can design the minimum diameter that we can use for the road. Okay. So that is adequate to support the 30 kilonewtons of the load. Okay. Okay. How can we get the P? Okay, P is from this one. P is from this one, BC. Because this one is the if you compare this one, the diameter is much smaller than this one, right? Okay, much smaller. FBC. Okay. If you calculate this one, of course, the what is it? The diameter is much larger lah, rather than this one. Okay, that is the load. Okay, how determine whether one piece section at the can get P. Okay, P this one whether from this member or this member, depending on which member that we want to use. Okay, actually you can analyze for both, whether BC and AB. No, not pressure, not pressure. This one is the definition, not pressure. It's a force. A load. We call it load lah. Force lah, same. Okay, this is the definition. Force intensity on that section. This one. This one. Okay. Because there's a section by section, right? So many, right? Okay. So as average, we define to the P lah. It's still a force. This is also section by section, right? Very small section. Okay. That's why you use a sigma average. And an area is total average of each section. Okay, this one not small. This one small. The repeating unit. Okay, we call it as a repeating unit. Okay, is it clear? Not pressure. Not pressure. This one we use a P lah. Okay. F is maybe you use a method of section. Okay. Actually, it's the same. F and P. Okay, don't worry. Okay. So we look at this example. Example. Okay. Okay. So if you look at here that two solid cylindrical rods AB and BC are welded together at D and loaded as shown, knowing that D1, okay, D1, this one, and 30 millimeter, and D2 is 50 meter. Find the average normal stress in the midsection of rod AB and BC. This one, between this one. So what you have to do, of course, okay, don't forget to draw a free body diagram. Okay, if for me, I will draw like this one. I use draw the line, right, like this. Okay, okay, so that we can see actually. So if you draw the free body diagram, right, okay, you cut lah. Sorry, lebih pula kan. Okay, and you cut here kan, and we see right. Okay, then what else? It said cut uh, another one. Okay, this one, this side. I draw like this lah. Okay, generally, because we can see clearly. Okay, from the whole picture, whole photo. Right? So this one just 60 kilonewton. So this one 60 kilonewton. Should be opposite lah. Okay, this one PAB. This one PAB. Because this one is point A, B, and C. Okay, don't forget also this one. This one also don't forget. 125 kilonewtons. For free body diagram, okay? And then you apply free body diagram for the cut section. Okay, similarly also for this one. Okay, 16 Newton. 6 kilonewton. Opposite side, this one. Okay, PVC. Okay. See, you see right where you cut just now. Cut this one. Then you cut one and rod BC. Okay. And then you can calculate by using method of section. Okay, which is calculate the this one lah. If you look at here, that just opposite, right, this one. So PAB is equal to 60 kilonewton lah. Okay, to calculate the, what is it, average normal stress, PAB, sigma AB lah, divided by cross section lah. Cross section for D1 is equal to 30, right? Okay, so you can get, what is it, cross section, this is just a road. Okay, a road pi d square per 4 lah, divide by 4, right? 34.88 megapascal. Okay, so you get the PAB, right? And this one they have include also 125 kilonewton. Don't forget. Sekejap ada calling. Hello. Bisa tahu. Okay, so that is to calculate sigma AB. Okay, so if you look at here, we determine already the PAB. Okay, PAB we determine, and also the sigma. Okay, so we have to consider this one lah, second cut section. Okay, so don't forget this one 125. Okay, this one we don't consider because we cut before point B, right? Okay, so for the road BC, meaning that BC lah, A, B, this one B, to the C, right? Okay, road BC, you have to consider 60 kilonewton. Okay, 100 negative 125 and 1225. Okay, this one. Okay, FX lah, total FX. Okay, total FX. Allah, saya just tunjuk ni lah. Ada jawapan kan. Total FX. This one is total FX. 1, 2, 3, 4. Total FX. 60 kilonewton 120. Kenapa dia define ke kiri but positif? Okay, this one is should positive, positive, positive. Wait. Berapa? Sama dapat should be compression. Should be this one should be. Okay. Is the definitions. It doesn't matter. It's depending on your definition actually. If 6 negative 60 plus 125 plus 125. Okay, 190 lah. Positif. Okay. Oh, betul lah. Sorry. Yeah, Y is positive because if total Fx, okay, Y is positive. If you total Fx, go to 0. Okay. Okay. PBC to the right side, right? PBC. PBC minus 60 lah. Plus 125 plus 125 go to 0. Okay, this one you bring to the right side. So compression to this side is correct. Okay, definition to the right is positive. So you calculate PBC can get. Okay. So if you want to use negative, we know that is compression opposite side or 190 kilonewtons. And make it bracket is compression. That's all. It's correct. Okay. So we can get answer road A and A, B, and also B, C. Okay, is it clear? How to calculate the axial load and the normal stress? Any questions? We have another 10 minutes, so I just go through the shear stress. So next week, maybe we will discuss some examples. Okay, maybe 1 or 2 examples. Actually, the solution is there. Okay, you can read first. I just pick up 1 or 2 examples and we discuss. Okay, and we can start with the new chapter 2. Okay, is it clear about the normal stress? Because we want to move to the shear stress out in within 10 minutes. Okay, clear. Okay, good. Okay, for the shear stress, okay, for examples, you imagine, okay, you, how to say, you give a force here and another force here. Is it going to be shear here? Okay, it's going to tear apart, something like that. So we apply the force transversely for the member. This one is for the member AB and A and B lah. Okay. For example, right side you apply force P, and the left side you apply the force P, right? So there's a shear stress here. Okay, there's the external force there. Okay, usually we use a symbol of V lah. Okay. Similarly, also this one, right? Because you pull this one, and then this one you hold, right? This one you hold. For example, what? You hold this one, right? So there's a force there, opposite side. Okay, this one is there's gonna be internal force. We call it as a shear force. Okay, so because you apply a transverse, the opposite force you apply. Okay, so for this cut section, there's a shearing force. Okay, we call it a shearing force. Okay, this is because of the this is the definition, resultant of the internal shear force distribution, shear of the section, like you, how to say, kalau you koyak junk food kan, dia punya packaging kan different different direction you can open the food packaging. If you do the same direction, I don't think you can open both hand. You do the same direction, I don't think you can get open the food packaging. Okay, okay, okay. That is the same. Kita buka penutup pen. Penutup pen. Ah, penutup pen. Penutup pen. Yelah macam tu lah. Tapi not a penutup pen. It's the same force. The same the different there's a different opposite direction for each force. Okay, whether you downward, upward, maybe if your hand you put on your table, right? You put on the table, right hand, you push your top of the tables, and your left hand you try to push upward, right? Something like that. There, you have a table, right? Okay, you press your tables or your right hands, and then another one you try to push upward for your left hands. So they have gonna be shear stress between your left and right hands. Okay, for the if your tables you set as A and B lah, point A and B. Okay, okay, okay. So usually we define yes, inversely, Nabila. Okay, inverse. This is what we call it as inverse lah. This is for example, this one, right? Table, right hand, okay, to the downward you push, and this one to the upward, okay, the force. Okay, okay. So there's this one. This one we call it as there's a shearing stress, a shearing force. Okay, so we use a symbol of TAV, tau. Okay, similar like if normal stress you do like this one, either you push or you press or pull. Okay, there's going to be tension and compress. Similarly also, this one later we will calculate the V. Okay, okay. So corresponding average shearing stress inside here is a tau AV. Okay, P divided by. For example, this one, right? Okay, so you're trying to push this one with the 6 kilonewtons. Okay, there's a cut section here, right? Okay, just the imaginary. This one also 6 kilonewtons, same force. So of course, if you do the free body diagram, just take this part. Okay, there's a force here, opposite side. Okay, if you look at here, because the cross section is the same, this one. So this is a 3 kilonewtons, 3 kilonewtons. How can we prove? If you look at here, right? 6, -8, and -5, right? So we can get each is a 3 kilonewtons. Yeah. So that's the meaning of the how to we determine. Okay, we just take this section. Okay, and after that, how can we calculate the V, right? Because there's a shearing there, a shear stress. We define here as this one is inside here VA lah. This one inside here is a VB. Okay, so if you look at here that we take a cross section for AA just now, this one. See, because you push over there, so it's going to be opposite. Okay, yeah, faham eh? Okay, mana AA BB? Oh, sorry. So this one, this one AA. AA is going to be the same lah here. BB here. Okay. So if we take that section for AA, because you give a force to that direction, so internal is going to be opposite. Okay, you just calculate total FL, you can get 3 kilonewtons. Just opposite direction. Okay. How about the point BB, right? BB, because you give a force to this direction, right? Of course, if you take the cross section for this one, right? So your this one, right? So because you give a force to this direction, the opposite side for the point BB, this one, right? Okay, so you cut here, right? You cut, you can get this one. Meaning that 3 kilonewtons because just opposite side to the right, and for VB is going to be to the left side. Okay, you just calculate the VB. Okay, and calculate the shearing stress. Okay, 3000 and 3000, only the area is the difference. Okay, if you look at here, the area for AA is what is it? This one, right? This is the area lah. The length. Okay, so that's why it's just different because of the area. Okay, if the same is the same, okay. Same area. Okay? Is it clear? I mean, ah, sekejap eh. Sekejap eh. Ah, oh, sekejap. Sekejap eh. Okay, is it clear? Sorry eh. Okay. So 200 kilopascal and 160 kilopascal. So just remember that sharing force is external lah. We use the symbol V. Okay, this one. Okay, so we finish. Okay, next week we discuss the example. Okay, any questions about the normal stress and sharing stress? Any questions? Okay for me. Okay, everyone is okay, right? Okay, I hope this is clear. If you are not clear, you can watch the video again. Only the example, I think we're going to take some time for example 1 or 2. Within 1 hour, we can discuss next week before we move to chapter 2. Right. But please read first. If you don't understand, you can ask. But it's actually is a direct, how to say, the calculation is quite direct. Okay. Okay, just I would like to remind you the definition of x-axis, y-axis not only to this side or to the left or to the upward, okay, to the right or to upward. Right? It can be this one, right? We call it, what is it saying it? Slanted, a little bit slanted, right? Okay, a little bit slanted. It's depending on your calculation because we want to reduce the number of unknowns. Also, sometimes the calculation is tedious, so we try to reduce the calculation. Okay, so it's a little bit slanted. It's slanted, right? Okay, lean. Yeah. So it's not really to the upward or to the right. Okay, it can be little bit slanted. Okay, that's all for today. If you have no questions, thank you very much. See you next week. Please read first. I will just pick up 1 or 2 examples for the discussion and before we move to this one, chapter 2. Okay, thank you very much. Anyone still not scan the QR codes? You want me to share?